Okay, here we go. So what I'm going to try to do here is just as a follow-up to that last video on basic differentiation of trigonometric functions, just some examples if you don't mind. So here's the first one. F of x is equal to cosine 3x. And if you go through the examples, we know how to read this now. Also, keep in mind that I entrusted to you that you would memorize these derivatives. So the first derivative of cosine of f of x is actually equal to opposite sine of f of x times f prime at x. Looks like the chain rule, doesn't it? Okay, so if we do this by pieces, we get f prime at x is equal to, well, the opposite of sine f of x, of course, was 3x. So all I'm doing is filling in the blanks from here to here times, well, what is the first derivative of the inside of 3x? And that derivative is 3. So quickly, we come to the conclusion that f prime at x is equal to negative 3 sine 3x. Got to be careful here. All right, I think that one was really straightforward, so let's try to move something to something a little more difficult. Not a ton more difficult, a little bit more difficult maybe. And let's look at this, please. Let's look at this new function and let that function be that y is equal to 3 tan of 4x. Keeping in mind, this is just a constant multiplier out here, so I'm not going to worry about this too much. I'm going to look at this. So we know that what we're going to do here is that we're going to take the derivative of this, so 3. The derivative of tan is secant squared x, isn't it? Times the derivative of the inside piece, which is 4. So here's our constant multiplier. Oh, let me fix that. That's what my mistake was. Of 4x, right? Of 4x. So the answer here should be, excuse me, 12. Wow, 12 times secant squared 4x. Okay, good. Let's move on to the next one. Okay, so moving on. I feel pretty good about this, I think. Hopefully you do. Hopefully you're taking your time and looking at how this. If you're getting confused right here, stop. Go back to the part 1 video and go through how the parentheses go through, and then secondly, ask yourself the question: do you have all those trigonometric derivatives memorized? You should have all 6 memorized for not only the function of x, but of f of x. So hopefully that's something you have done too. Let's try this next one. It's y is equal to sine of pi x squared. And what I'm going to do is I'm going to just follow some really easy guidelines here just to simplify this for myself. I'm going to distribute this square into here. So I'm just going to rewrite this as y is equal to sine of pi squared x squared. I cleaned it up a little bit, and now remember, now we have sine of f of x. So remember that the first derivative of sine of f of x, the first derivative, is equal to cosine f of x, isn't it? Times f prime at x. That is the inner part of the derivative. So just to do that first, we'll get cosine pi squared x squared, and then times the derivative of the inside, which is, be careful here because you're not going to take the derivative of pi. This is not a variable. This is a constant value. So it's going to be 2 pi squared x. And just so you know, this 2 right here came from this 2 as I brought it down to take that derivative, right? So we're almost finished here. So y prime is equal to this. Simplify a tiny bit, and our derivative, y prime, will be equal to 2 pi squared x cosine. I'm going to bring this thing back out just to clean it up a little bit. Pi x squared. All right. Okay, I think we're doing great, actually. Hopefully this is working for you. Let's try one more, and I think this will remind us of what that last rule, the one that we struggled with a little bit in class today, was. So let's just look at that and see if we can't figure this out. We have y is equal to 4, constant multiplier here, secant squared x. And I'm encouraging you please to stop for a second and remember trigonometrically that what this means is y equals 4 times secant x squared. This squared right here is this one right here. Okay? And I think from there we can start making some progress here, can't we? So take the derivative of the outside times the derivative of the inside. So the derivative of the outside is 2 times 4, so let's start with y prime. Y prime is equal to 2 times 4 equals 8. Remember that it's still secant x here because we're not taking the derivative of the inside. And the derivative of the inside, you have to remember this, that, where am I going to write this? To find a place here. The derivative of secant, right? The first derivative of secant of x is equal to secant x tan x. Again, you have to commit that stuff to memory. So all I'm going to do is I'm going to put that derivative in here, and I'm going to take that derivative, and it's going to be secant x tan x. Right? If we multiply all this stuff together, look, secant, multiply this times this, we'll get, here's our constant multiplier, so here's that. If I multiply secant x, we get secant, remember, squared x times this tan x, tan x. And I know that, well, hopefully you're aware of your trigonometric identities, and you can switch this out, right? This is 1 over cosine here. This is 1 squared over cosine squared here, and this is tan of x is, of course, sine over cosine. If you multiplied those out, you'd get a fraction here, and that would be 8 sine of x over cosine cubed. Because remember, this would have been it would have been 1 squared over cosine squared, and this would have been sine squared over cosine squared. So it would have been sine over cosine. So cosine squared times cosine is cosine cubed x. That was really hard to say. Okay, if you got here, I'm really, really happy. I feel really good about it. I truly do. If you got here, that's great. If you want to know how to get to here, that's even better. Okay, so hopefully this is getting better for you. Give me some comments. Let me know how this is going, and we'll work it out. Keep up the hard work. Memorize those identities, please.